Figure that out. Okay, so hopefully I'm recording again for the final presentation. So welcome, rather, it's a pleasure to welcome Christine Mundy, joining us from the other side of the world, from the Department of Chemistry, University of Pretoria, South Africa. So in my opening gambit, I referenced the Gordon Conference and meeting, well, not meeting, listening to Sylvia last year at last year's GRC. And I was reflecting that Christine and I met, I think it must have been 2011, maybe 2013 at GRC, and we shared a love of cognitive load and thinking about learning and working with learners in chemistry and higher education, and that friendship and collaboration has continued since then. So it's a real pleasure to finish the symposium today with Christine and her presentation. Christine has been working at Pretoria since 2012. She's currently a lecturing course coordinator there. In 2022, Christine is another amazing educator, has lots of institutional prizes and prizes from various organizations, including probably the most prestigious one, the South African Chemical Institute's 2022 Medal for Chemical Education. Christine, you're going to have to help me here. I think it was 2022, but you can correct me. She was awarded a PhD for her research, which encompasses some of the topics she's going to talk about today. Would you please join me in welcoming Christine? Christine, I'm going to stop sharing my screen now, so that means you should be able to share yours. And when you are ready, the floor is yours.
Thank you, Michael. Just give me a second.
Okay, that's coming up. Lovely. Thanks.
Coming up. Excellent. Okay, so today I'm talking about language as a medium for inclusivity. We usually talk about language as the medium for instruction, but today I want to talk about inclusivity and how we instruct chemistry education. This is just a photograph of my campus. As you know, we are in the Southern Hemisphere, so we've just gone from spring to summer. And Pretoria, my university, this is a picture of the campus, is famous for our jacaranda trees, the beautiful purple jacaranda trees. My office is just hidden there behind some jacaranda trees. I am from South Africa, as Mike mentioned, and in South Africa we have 11 official languages, excluding sign language. So we've got 12 official languages that we're dealing with, and a very diverse population in terms of socio-cultural and economic variables. When we just look at our education system, I'd like to give you a little bit of background in that we are dealing with a bimodal schooling system. And what is meant by that is our schools can be divided into quintiles, quintiles 1 to 3 being non-fee paying schools, and those are often termed dysfunctional schools. And that's approximately 80% of our learners that come from high school into tertiary education are from these dysfunctional schools. Another point of interest is that the students from the quintile 1 to 3 schools are often taught in their second language. A lot of our instruction in South Africa occurs in English, and these learners are often learning in a second language capacity, whereas the quintile 4 to 5 schools, which are well-resourced schools in which students pay fees, the students are often taught in their mother tongue in those such schools. So from a particularly South African perspective, you can see we've already got a large case study in terms of language. And then one's got the challenges faced by all chemistry students, whether you're in South Africa, you're in the UK, anywhere in the world, you will need basic proficiencies in maths and language. And then chemish, like Sylvia was talking about, the language, the scientific language of chemistry, in which we need to both understand and converse, explain our understanding. We also had mentioned today of Johnston's triangle or the chemistry triplet. So those are different levels that the chemist needs to transverse, and language is the medium which links those levels. And the ease between expert and novice is also shown in how easily an individual can jump from one level to the other level within Johnston's triangle. Like Mike was saying, we met over a love of cognitive load, and chemistry and chemists have that in abundance. We juggle lots of mental balls inside the classroom and inside the laboratory, and especially the laboratory is termed a complex learning environment, because one is trying to interpret what you are seeing on a macroscopic level with the submicroscopic and the representational, and you're trying to link it all together with language. So you can see even the little diagram at the bottom, the instructor is talking one language and the students are seeing a representation on a different level and trying to make sense of it. So just for today's talk, I know there are lots of ways of delineating language and the language used in our classrooms. So I used the definition by Uyo, who's a South African author, and Kunles, where they divide language into being technical or scientific words and non-technical, which are everyday words which take on a meaning in the scientific context. So we can all agree that we've got discipline-specific words like photon and quantization. Those are words that don't exist outside of our discipline. Our discipline also has terms with evolving meaning, for example, the atom. And we've got our vast array of symbolic languages, from symbols to symbols on the periodic table, to how we draw different diagrams, bonding diagrams, energy diagrams, etc. And then we've got our non-technical terms that we use. For example, excited means something different in the sciences as to in everyday life. And we've got the teleological terminology and anthropomorphisms that we like to use to explain atoms sharing electrons, an atom wanting to bond. Atoms don't have emotions, feelings, desires, but we use those words to try to convey or to converse with our students about what's going on. So this all leads me to the idea that language is a gatekeeper for inclusivity in our classrooms. And what we really want to do is create inclusive classrooms. So we want to ensure that quality education is ensured for all students, given their diverse needs in terms of prior knowledge and their linguistic backgrounds. So what I've come across in literature, and it's a very nice, short, sweet framework. It's called the Universal Design for Learning by Rose et al. And it gives ideas for making our learning inclusive. And each of these ways, the multiple means of representation, the multiple means of expression, and even the multiple means of engagement, have a linguistic component to them that you can, as an instructor, target. So what I want to show here is just a little snippet from my PhD. What you can see is students have built, it looks like a tiny little asthma pump, but it's not. It's a mini spectroscope, and they are observing different light, and they're beginning to form concepts such as discrete and continuous spectra. And what you can see on the right-hand side is a template of what this little mini spec looks like on the inside, and then you can see a fully built mini spec. And when we're looking at multiple means of representation, here there was a JCE article where one group of students was given a list of instructions on how to build their mini specs, and the other group of students was given actual templates in the lab, like the templates you see on the right-hand side, partially formed and fully formed templates to supplement the written instructions. And here you can see the results that we found. On the left, we can see those that were given the templates, that's the intervention group, required less time to construct their mini specs. And to add to that, on the right-hand side, they performed statistically significantly better when they were explaining their results. So what that led us to believe that by decreasing the language demands on the students, we were able to make more cognitive space available for them to process what they were actually doing in the laboratory. And then when we look at the universal design for learning in terms of multiple means of expression, here you can see a little picture. These are some of the hurdles or barriers that students experienced in the lab. There was the jumping and dropping of electrons, which I'm going to talk about a little bit more. But then there was the fact that students were mixing up words like diffract, refract, and they were making up their own words like defract. And the idea of building knowledge around the terms discrete or continuous, those are both, believe it or not, considered everyday terms. Discrete means isolated or separate, and continuous means ongoing. But these are terms, even though they are everyday terms, they're terms that second language speakers do not have access to. Their vocabulary doesn't expand to such terms. So we found that trying to scaffold students' understanding of the term is fundamentally flawed if they've got no everyday way to relate to those terms. So students were constructing completely incorrect meaning for discrete and continuous because they had nothing to scaffold against in terms of their vocabulary available. Another interesting thing was the symbolic language. At the top, you can see where we're talking about a helium atom just hypothetically being excited to the n is equal to 4 level. And we asked how many transitions, how many emission lines would be seen in an emission spectrum. And students arrive at the answer of 6 emission lines, but they leave out so much detail. They leave out the electron, they leave out the photon. All they really focus on is the downward transition. And for 4 marks, you would expect that the marks would have guided the students to make their explanation richer, but you can see that they're not accessing the symbolic language vocabulary either. And finally, another result from the study was that when we use simplified or anthropomorphic terms, and I know this is very similar to other points in literature, for example, this multiple choice question, which was devised in literature, and when I forgot to put the reference, but the people who devised it said it shows up every misconception in terms of spectral line formation. And when I gave it to my students, only 61% of them got the answer, and we thought we were doing a really good job teaching it. And so I actually listened to students. We were listening to students discuss this problem. And the big reason why they weren't choosing B was the word jumps. The second language English speakers saw jumping as only an upwards motion, whereas when we talk about electron transitions, they can be upwards or downwards. So all I did was change the word jumps to drops, and the next time round we had 74% of the students get the correct result. Now on to a different study, the interface of maths and chemistry. What I wanted to exhibit here again is, we'll see in the results, but language is the binding thread between chemistry and mathematics. So here are two problems. The students, we have what we call a common test. That's like a class test. And then 2 weeks later, students did a semester test. And we tracked their performance from the class test to the semester test. And you can see the questions are of a fairly similar standard. And what we saw was we were able to group the students into different categories. So let me just explain here. Getting out my teacher laser pointer. So for those that performed poorly in the first test and then performed poorly in the second test, in the semester test, we classified those as low. So 20%, 27% of our class, and our class was fairly large, 265 students, performed poorly in the beginning and in the end. And again here, those who performed well in the first test and well in the second test, the high category, that was 30% of our students. But what we found that really shocked us were these two categories. We had very few students improve in performance, and we had a quarter of our students decline in performance from one assessment to the other. And when we analyzed the test scripts of the students, we found that the breakdown occurred when students had to go from a chemistry conceptual model to a mathematical conceptual model. And the link between those two models is interpreting the language, the terms written in the questions, and then formulating their own algebraic equations after that. So that's what I'm saying here. In this model, they call it mathematizing, but it really is the interface between chemistry and mathematics, where language becomes the barrier for students going forward. So what I would like to say in conclusion is that as educators and as researchers, one needs to be aware of the challenges faced by students and be responsive in creating inclusive environments. Language is one of our biggest gatekeeping areas for understanding the science, being able to communicate in the science and converse in the science. And as we know, language can itself create a huge cognitive load on students, regardless of whether it's technical or non-technical. And counterintuitively, it is the non-technical language for second language speakers that seems to create the highest load on students. So where you think you are simplifying it by saying electrons are shared or electrons jump or drop, you are actually creating more problems than if you just said electrons were transitioning between energy levels. So this non-technical load, I would say, would probably be the most difficult for instructors to identify. And that then hinges on a component of pedagogical science language knowledge. So not just of the technical terms, but what does it mean when non-technical language comes into play? And I wanted to reiterate again that small changes in terms of language in the classroom can have fantastic consequences. Those are my references, and I would similarly like to thank Michael Seery for this opportunity for speaking here, and the Royal Society of Chemistry. Thank you very much.
Lovely. Thank you, Christine. And I'm familiar with some of that work, but it's so lovely to see your work in the maths domain as well, which has definitely caught the interest of the audience. So just before we have some questions for Christine, I'll just say that we have about just over 10 minutes left. So what I'm suggesting is we'll have some discussion with Christine, but maybe if people are interested, we've got 4 experts here, and I hope the symposium has shown you 4 different perspectives and thinking about language. If there are questions more generally that we can bounce to the panel, we can use that expertise while we have them. So let me just check. So I guess one question really was around this mathematizing, or what we used the old-fashioned term of the maths for chemistry problem. What kind of challenges were you able to unpick there? Was it literally just the sense of how to translate what was being asked into a maths question, or was it the phrasing or the construction of the way the chemistry question was asked?
The questions had very simple language where we said one isotope was equal in abundance to another. So there was just the word equal, or we said that they had their sum was equal to something else. So it was the word sum or equal. So the words themselves were not challenging. But what we've also found is there is a very effective link as well with our students. As soon as they see language that they are uncertain of, there is a whole emotional and confidence issue as well that comes into play. So when we interviewed the students, so we analyzed the scripts, we saw where the problem was, and then we started interviewing the groups of students depending on which category they fell in. And those students that did not progress or showed a decrease in progress had very little confidence in their skills in terms of mathematics and in terms of language. So there's a confidence portion as well.
Yeah, I mean that drop is, yeah, I can imagine that's quite an interesting moment as a teacher thinking, yeah, what's happened?
Yes, and we've done extra examples with them, more challenging examples,
Yeah.
everything to get them ready for the test. And then we have a quarter of them do more poorly than they started.
Yeah. A shout out around the UDL lens and appreciation for that. And Nikki has a question, if I can read it and see. So non-technical load may be the most difficult for instructors to identify. And she echoes that there's a really important point. And thinking about, can you see specific vocab being easier to learn, whereas other aspects are, I guess, more difficult. So I guess this is the question, Nikki, you might have to help me clarify. This sense around the way in which we teach particular vocabulary. So I think, for example, when you're talking about jump and drop, two words we've had long conversations about. How do we manifest the teaching of these often very specific terms in our science teaching?
I think we should not be scared of scientific terminology because students need to build that vocabulary. So by moving away from scientific terminology, we are removing from them the opportunity to become more expert in the field by defaulting to everyday terminology, which does not encompass the fullness of the definition of scientific terminology. And one must also remember that scientific terminology is a second language for everyone, whereas non-technical or everyday terminology might be a second language for a few. So rather, everyone builds a more sophisticated understanding together than excluding those students who do not have the vocabulary to work with.
Yeah, thank you.
I don't know what people think of such an answer, if it's very controversial.
Yeah, well, I guess we'll see now in the chat, but yeah, I mean, I think I'm agreeing with this. So what I'll do is if and I hadn't prepped them for this, so apologies, but if the speakers would like to rejoin the conversation, I thought it could be hard. Sorry, I'm reading a question while I'm trying to speak. I thought it could be interesting just to get some more broader perspectives. And one of the, I guess one of the questions is, the so what question, in terms of you've each shared different aspects of language, and many of us in the room are thinking about this from a teaching perspective. And what if you had kind of core messages to take away about teaching and what this means for teaching chemistry? What's your kind of salient headline message? So there you go. I'm throwing you in the deep end. Naomi, you have your hand up. Go for it.
I think, I think we've heard it from everybody in some way, shape, or form, that awareness is the start And it's through personal awareness of what we're saying and doing and awareness of potential pitfalls that things can slowly be addressed. And remembering that what works with one particular group of learners at that moment in time is not guaranteed to work with the next.
Yeah, thank you. And Sylvia, yeah?
I would follow up on what Naomi said. So I think the first step should be that each teacher, but I have to admit also we, because we use scientific language in our university classes as well, that we have to reflect on our practices. So especially when we're in educating future science teachers, future chemistry teachers, I think we have to be kind of their role model, is the word that I use. And I think the first step is actually reflecting what we are doing and reflecting how we are doing because it's more or less they're gonna mimic us. They're gonna, do what we are doing when they're teaching. So I think the first step should be that we reflect on us and also put it in our chemistry classes. I know it sometimes hard because we are all good, but I think reflection is something which we should do as well.
Yeah, Maxine, I guess you've considered this very much from a teacher-developer point of view as well. I mean, there's this sense of, can you condense this sort of, lesson for practice almost?
I was just really struck by what Christine presented there in terms of real evidence of the need to reduce the cognitive load.
Mm-hmm.
And when, for me, I'm working with people who are working in a second language, and the need to do that thinking time, have that private practice before public performance, that they're not having to deal with the load of processing the content as well as processing the language at the same time. So whatever we can do to highlight and simplify the linguistic element. And I think one of the things that struck me when I was attending that year of chemistry lectures, and I can't remember how many, 7 or 8 different lecturers, and the one that all my second language learner students preferred was not the one that I would have anticipated. It was the one that lectured as if he was a textbook. Because he was using just the same formal chemistry language that they were reading in the textbook, so it was easy for them to make those connections. Whereas the ones that were using all the slang and trying to be friends and that informal language was just another load, and they couldn't make those connections between what was written on the slide, what they'd read in their books, what he was saying. Was it the same? Was it different? So yeah, that idea of being very aware of the language that we're using and trying to, I think Sylvia, it was you or somebody mentioned, select the language that you want to use and be consistent about it. I think is
yeah. I mean, I that awareness. I was sort of struck when you said earlier about making sure that when you implicitly explain a term as you introduce it, that you say explicitly you were saying that. Because I know in teaching I do that a lot. That sense of I just assume because I'm saying those two things together that the assumption is the student is making that. So I think that kind of explicitness is very valuable.
That flag, those organizers, those words to say, in other words, by this I mean, because it's so important. I was really interesting sitting through a whole lecture where the students had missed the sort of introductory word. I think she said supposedly or something like that. So everything that came after was not her belief. It was not correct, but everybody was carefully writing it all down because I'd missed that one word. So it's really important to guide the listener in the same way as we do in writing, guide the reader, isn't it?
So Michael's put in a question here, and I have a separate question as a private question, and also just what you'd mentioned there. I'm going to try and synthesize these 3 things into our final thought for your response. So Michael's asking about independent reading. In other words, something the students are doing outside the classroom. I have a question in the background about teaching in, but using local dialect to kind of, or slang, I guess, or maybe even analogies, or some ways in which we can help the students understand alongside the technical terms. And Sylvia, you mentioned earlier about students being exposed to, TikTok or external sources. So as well as the kind of maybe very carefully thought through, caring teacher environment that we might try and construct in our classroom, students have been exposed to language of various sorts and not externally. And I'm just wondering, have you any thoughts about what that means from a language learning point of view in science? I'm not sure I synthesized that question very well, but hopefully there's something there to discuss. So Sylvia, your thoughts on this kind of TikTokification of these influencers that are influencing what students think about in terms of their understanding.
Yeah, I don't have any studies on this. This is more or less like when I was talking to the teachers that visit us here in our student laboratory. They said that the kids are often not studying at home with the books or working sheets that I get from school, but just listen to the YouTube videos. The problem there is that like those fancy made with sparkly here, sparkly there, let's say, videos are not made by scientists or by science teachers or by us. Those are usually made by people who have a huge army of graphic designs and so on and so on and so on, and they are mainly not scientists. I also listened to somebody who he said that he stopped doing school before he finished, actually, before he graduated upper secondary. He didn't like the school at all, but he kind of get into this influencer thing, YouTube thing, and this is kind of the gap. So that's why he's doing, but he has no clue about chemistry. But he has, let's say, the money and how to make those fancy videos. And the problem is that the videos and the explanation are very basic, very wrong, so reduced that they suddenly became wrong. And this is what they're looking. They're not looking to the videos of a teacher who is standing in front of the blackboard and writing. This is boring for them, and this is just not cool. So this was the problem, what they say, that the language which is used is very simple, more like, they say sometimes more like Facebook German, not so many scientific language, but in some points when it comes to the concepts, to the content, completely wrong. So
yeah. Any other thoughts?
But as I said, I don't have any studies.
Yeah, no, but I think
I mean,
the reason I'm thinking about it is because Christine's work really, showed that the power of a student perception of one word, jump, had huge ramifications in terms of their understanding of spectroscopy. And I'm just thinking, if students are gaining these words from an external source that's really embedding a particular perspective or meaning for them, that could be quite difficult to deconstruct then in formal settings. So, yeah.
Can I jump in there?
Please do, Christine, yes.
I think the social media age is something that we do need to leverage. I know Sylvia is saying that it's sparkly and it's often wrong, but I think, again, as experts guiding novices, we can do a little bit of homework and direct them to the right type of supplemental instruction on YouTube, etc. I know I spent a little bit of time during the lockdown, and I created a YouTube channel. And for my students, they watch it over and over and over again, because those second language students don't often catch everything the first time around. So that opportunity to listen to it over and over again, one just has to make sure that the content that they are listening to over and over again is the right type of content. So I think that presents an additional challenge for us, and we have to navigate these platforms and guide our students.
Thank you. Christine, to sign us off, I'm going to add YouTube influencer now to the long list of accomplishments on your CV. So please, we are just gone past time. So thank you to everybody for keeping time. I really appreciate the expertise shared today at a very busy time of the year for everybody. Thank you to everybody tuning in. We will slowly sign off, but would you just please join me again in thanking everybody for their presentations today, and for the audience for such great interaction on chat and elsewhere. Thank you.
Thanks again for the invitation and for listening. Thank you.
Thanks, Sylvia, and enjoy the Christmas markets. Not that I'm jealous at all.